Good day, dear colleagues. The topic of my report, construction features of the industrial environment control system. SCADA is an architectural scheme of industrial control systems with many components that are often distributed over a wide area. SCADA is a critical information system. It critically stems from the fact of the SCADA systems are vital components of the critical infrastructure of most countries. They control pipelines, water supply, and transportation system, utilities, refineries, chemical plants, and a wide range of production operations. A failure from managed systems can result in direct loss of resources due to the equipment shutdown or indirect damage due to critical infrastructure failure, controlled by SCADA. SCADA as a critical information system faces the same challenges as other types of information systems, such as dynamism and openness of the environment, efficiency, complexity processing, reliability, sensitivity, heterogeneity, evolution, flexibility, and security. SCADA systems are now gradually relying on standard utilities and protocols of information technologies such as TCP/IP, Internet, wireless technology, and other. The reason of this is to achieve interaction and to reduce costs. SCADA provides real-time data management of production operations, implements more effective control paradigms, improves the condition and safety of personnel, and reduces operation costs. At this time, utilities are still purchasing SCADA systems and are largely dependent on SCADA vendors to configure and maintain these systems. The main problem in the field of SCADA systems is their deployment in large enterprises and their integration with disparate platforms. At the forefront are the problems of aggregation of information SCADA systems from disparate nodes, which without proper protocols make it impossible to continue working with MIS and RP systems. On the other hand, there are problems of integration within the corporate information system, namely the heterogeneity of information flows. Given that building a system based on the Bandera system platform opens a radically new perspective on the system's deployment in industrial enterprises of various sizes and the ability to save resources when setting up and maintaining the system. The market of SCADA systems nowadays is quite large. They all have different capabilities in terms of convenience, cost, and speed of development. Today, the main problem is the creation of large projects with many elements of the diagrams or the need to calculate large amounts of data which significantly affect the speed of the system. Attempts to solve problems departing from the built-in capabilities of the SCADA system usually lead to solutions of great complexity with the corresponding cost of the resources. The reason for this is the closeness of the internal structure and problems with documentation, which should provide comprehensive information about the types of data storage and database structure. At the moment, in the software development market, most of the time is spent on creating new functionality rather than optimization of the systems and this testing. Despite the fact that SCADA systems are designed for industry which entails increased requirements for reliability and stability of the system, the market for the SCADA system is similar. Therefore, the process of system development requires spending most of the time in solving problems with documentation and errors that are not described in it than on the development of the system itself. One of the important factors is the high cost, because when developing a large industrial solution, the cost of the copy of the object can be €100. Unfortunately, open source systems do not solve the situation, as the union of stakeholders is limited in number. High workloads and low-quality software, unwillingness to waste time, and a low number of people interested in the product allow commercial products to be the market leaders. Having solved all the above problems in the ideal SCADA system must meet the following requirements. First is the speed of work. There should be no interpreters in the system. The reason of the system source should be machine code. Flexibility. The system should allow you to easily and with low cost time change existing components or add personnel and adjust them to these needs. Data structure. The system should provide clear information about the structure and types of data, settings, storage formats, and an easy way to build any reports based on this data. Complexity and speed of development. The system should simplify the process of scanning large projects, minimizing programming processes, which should be replaced by visual programming. Development environment. The system should provide a convenient and modern development environment that contains all the necessary components. Low cost when using third-party tools. The system should provide the ability to easily and conveniently integrate any components, third-party software products, third-party devices, and support all modern protocols. WinCC OA SCADA system has advanced user interface tools, such as graphical element libraries that meet modern trends in HMI, 3D objects, animation, etc. Tools for visualizing data flows, identification, advanced property editors, tools management of saved data panels, and also provides the ability to support visual programming, creating user interfaces for devices based on iOS and Android. And important aspects is the provision of the WinCC UA platform in terms of the data exchange with external systems, redundancy, construction of distributed architectures. At the same time, the various tools of WinCC UA, which provides ample opportunities in systems engineering, require the developer of high engineering education and responsible choice of design solutions that ensure reliable operation of the system at all stages of the life cycle, significantly increasing the cost of the system and complicates the development process. The complexity of the system does not justify the amount of functionality it provides, but only slows down the process of staff training and integration of new components. Another representative in the market of SCADA systems is web access, which with the help of this SCADA it is possible to build an automated control system for industrial processes, as well as to remotely configure and maintain the created system during operation. Building a system based on web access allows you to reserve control systems nodes for particularly responsible objects. In this case, web access set the priority of signal processing from the main and the duplicate nodes of the control network and switches to backup nodes if necessary. The web access graphical interface is made in the form of separate work screens. Each of them has only the necessary information, which is displayed in the form of animated chips and dynamically changing over time graphs. A distinctive feature of web access is the targeted support of HTML5 technology, a modern language of marking electronic documents. HTML5 language is used to build communication with an operator. SCADA working screens are built on this technology. The use of HTML provides appreciated opportunities, but also imposes certain limitations, namely the speed of graphs, signals processing, and their timely display to the operator, which is critical in the construction of large-scale industrial systems. Another problem with web access is problems with the integration of third-party services and databases, which lead to frequent errors and problems with access to the system. For modern SCADA systems, such processes are unacceptable, as they entail high costs or stop the industrial process. In the situation on the market of SCADA system, the main problems encountered in the products are analyzed, and the characteristics of what a modern SCADA system should have are derived. Several variants of the systems were examined, and it was found that not all of them fit the parameters of the ideal environment for the development of industrial projects. It was determined that this system should be commercial, as open source systems don't have sufficient resources to support large projects and rapid development of system modules. Taking into account the mentioned above, it's important to build a system in a modern SCADA which provides opportunities for rapid development of projects. An object-oriented approach was chosen for the design of the industrial environment system, which includes the construction of UML diagrams. Class diagram is one of the most important types of UML diagrams, which should reflect the logical structure of the simulated system and is the basis at the beginning of the system development. Classes and the relationships between them are part of this time diagram. Based on object-oriented programming templates, the class diagram represents the structure of the model, describes the different types of relations between objects, gives a clear description of the internal structure of objects and subsystems. Next. The sequence diagram shows 5 objects: administrator, engineer, template module, report module, and database, between which are the transmission of messages presented in the form of requests and responses. After creating a template and its mandatory configuration, the administrator begins to integrate the real sensor, which is a specific template. All information is transferred from the template module to the database within subsequent storage. After successful integration, this will be reported to the engineer, who will be able to start working with the sensor and receive information from him about the work in the system. In the event of a notification of incorrect operation, the administrator and engineer will be notified to resolve the conflict. Once the problem is resolved, both the administrator and the engineer will be notified. Package diagrams are diagrams that show the dependencies and the relationships between packages. The system of an industrial enterprise must solve the following tasks. First is creation of a data workers and the ability to write the data to external media. Development of an information panel that will provide the engineer with timely real-time information about the state of the enterprise, and development of a notification model that should signal conflicts in the system in real time. After analyzing the chart systems, the main function of the system is to create templates and easy integration of sensors. The presence of this system will speed up the work of the enterprise by reducing costs. It will provide the engineer with the necessary information about the state of the system in real time and will help to respond quickly and any failures that may occur. That is why this system has advantages to our existing solution. Templates are elements in the application server that contains common configuration settings for the instances of objects that are used multiple times in the application. Basic templates are divided into, first, application templates. These templates make it easy to create Galaxy devices. They contain properties that must be set for each device type. However, it's possible to add personal properties using attributes and scripts. Second is device integration templates. These templates are links to external devices. External devices run on the application engine. And third is system templates. These objects represent parts of the Galaxy and monitor control. The Bandera system platform acts as an industrial operating system for the enterprise by providing standard services including visualization, configuration, deployment, connection, protection, communication with the forkful data, data storage and management, staff interaction, and more. These services are the organization to create a unified model of the enterprise, which is a logical representation of work processes and physical equipment of industrial systems, including obsolete, which makes the development and maintenance of such systems more efficient, flexible, and less risky. The enterprise model shows in poster 13 also creates an important context for the data, provides significant assistance in diagnosing and eliminating deficiencies, and ensures that formation of important system documentation through the life cycle. One of the main advantages of the system platform is the ability to centrally develop, manage, update, scale, and maintain all automation system for management, data processing, and visualizing with a single, clear, integrated, and powerful environment. The main task of the Wonderware system platform is to build a system in the enterprise with access to information in real time. To build a quality business structure, manager and engineers within all positions must have access to information in a way convenient for them. The system based on the Wonderware platform allows you to receive information at any time in a convenient form and operate it to reduce costs and prevent risky situations. One of the most important components in this system is orchestra technology. It is a set of services running in the background on each of the computers included in the automation system based on the Wonderware system platform. This set includes all the services required for most automation systems, such as control of basic software version and project configuration, centralized system deployment and license management, real-time data visualization and monitoring, alarm and event management, achieving security support. The hardware of the system is built on the basis of Arduino Uno as a microcontroller for processing signals from the sensor. Each of the 14 digital ports available in the Arduino Uno can be used as input or output using the pin mode, digital write and digital read functions. They operate at the voltage of 5 volts. Each port can give or receive up to 20 milliamperes at the maximum operating mode and has an internal resistor disabled by default at the 20 or 50K. The maximum value is 40 milliamperes. This value should be exceeded at any input-out port to avoid damage to the microcontroller. In this case, the voltage of 5 volt and analog port AO were used to transmit information. The next component of the hardware is the soil moisture sensor UL69. This sensor is designed to collect water level data. It has a built-in potentiometer to adjust the sensitivity of the digital output DO, which is not used in our case. A power LED and a digital output LED. The sensor consists of my probe, through which is received information about the water level in the tank. The principle of operation of the sensor is simple. The current flow between the two pins of the probe. In the presence of water, the resistance between them decreases, the current increases, and vice versa. The main task of the system is to provide information in real time, in convenient and pre-selected from two users. To start the build system, you need to run it in appropriate environment. To get in appropriate environment, yes. To get started, the user must log into the system with the appropriate login and password to gain control over the required functions. After confirming his identity, the user gets the main page, which displays the two sections of this system. The first section, industry, is responsible for checking the state of industrial systems and the processes of the enterprise. The screen shows a simulation of real production processes with their corresponding indicators and industrial facilities. Next, the system allows the user not only to receive information in real time, but also to work with historical data, generating reports based on them. The system also allows you to download these reports in the user-friendly formats. Graphs are provided the system to display information about changes in indicators over time. By going to the Trends tab, the user gets to see the change of indicators from one or more sensors over time. The system also allows you to customize graphics according to user needs and personalize them. So, conclusions. As a result of this work, an industrial enterprise system was developed. The result of the work performed are as follows. The market of similar software solutions and technologies leading to it is analyzed. The main problems of market products are shown. The analysis of methods according to the theme is carried out, and the most expedient ones are chosen. The subject area of research was determined. The imperfection of software solution in the market that solved the problem was determined, and the requirements for the ideal system were formulated. As the structural process of system creation are described, rational unified process was used as a methodology to create a lost part of the product as the most important focus. In this case is the working product. All precedents with the methodology has been described. Formulated and described methods of implementation of the selected system given the minimum requirements for the software and hardware. The software and hardware solutions that meet the requirements for building an industrial enterprise system and the methods required for its implementation were selected. The information system of the industrial enterprise is constructed with the hardware part in the form of the microcontroller and software part in the form of the information panel. The detailed description of the designed system and the examples of its work is resulted. The result is a complete system for industrial enterprise ready to use.